Okay, in the last class we have defined what is the meaning of transfer function, and we have also derived the transfer function from impulse response. We have performed the convolution, and then we have concluded that rather than performing the convolution, it is easier to handle in frequency domain. Okay, so two conditions were there already. The transfer function is defined for what rest conditions, means your system should be initially rest. By saying that your system is rest or in a relaxed condition, it means that no part of the system should store energy at t is equal to 0. Okay, first thing. And second thing, we have seen that in transfer function analysis, this is also just applicable for input-output relationship, means no information about states can be obtained with the help of transfer function. Only you can get if you have given with input and in the transfer function, you can find out the output. Just that it is. Okay. So now we will try to solve some numerical based upon the definition of transfer function. Let us start with one of the mechanical systems. Okay. Suppose you are having a system like this, and going to start with very familiar system which you might have seen in your class 12, but some addition is here. You might have seen your mass spring system, okay, in your class 12, but here one damper I am going to see. This is mass M, force Ft you are going to apply on this mass, and accordingly there will be change in position, say xt of this mass. Okay. This is spring constant K, and this is B. B is what? Damping constant. Damping constant of this damper. Damper is somewhat like resistive element. Okay. Means it opposes your motion. It is having tendency to oppose the motion. And the corresponding damping force is given by F. I am going to say this damping damp will be equal to B multiplied by V. Means velocity of the associated object. Okay. Now try to solve this numerical, because only one thing which was not known to you, that is about damper. I have told you about the damper, how the force is going to oppose it. The rest you all is known to you, that spring is having force, spring force, that is K. It will also oppose the motion. So first way to approach this problem is to draw the free body diagram of the system. Free body diagram means you will take just mass into consideration, and you will focus on this, and for you it will be the system, and you will see what are the forces being applied to the system. So if you try for the free body diagram, you will get like this. Here it is mass M, okay. Force small Ft is applied by U. This is corresponding displacement of the mass xt, and if you will apply the force, it will move mass will move this side. So spring force will oppose this motion. So accordingly, F as spring I am going to say is equal to what? K multiplied by xt. Correct? And one more force having the tendency to oppose the motion, that is your damping force. I have said you should remember this symbol. This symbol particularly you should remember this. This is a symbol for damper. Means it is somewhat like instead of in real life you can consider it somewhat like instead of performing the mass spring motion in air, what you do, you place all the systems inside the water. So what will happen? If you apply a force, some drag force will always act opposite to the motion, and that drag force you can represent by the damping force. Okay, this is one of the examples. There are many other examples of this damping force. Okay, so this will also oppose the motion, and you are going to say F damp will be equal to what? V, you can say dxt upon d. That is very simple. Okay, try to apply the Newton's law, solve it. Take the Laplace transform and gravitational force we are not going to take into the picture, because if you will apply mass mc here, say for freedom of body diagram, we are going to apply mass mc here. Okay, it will be counterbalanced by the normal force. So there is no motion along the y-axis. So we are going to consider the forces which are being applied along the x-axis only. Okay. So why to make life more complex when it is already complex? So we have removed this. Write the force equation. Very simple. Ft minus F damp minus F spring will be the net force acting on the mass, and net force acting on the mass will be equal to mass into acceleration, not zero, because there is a change in position xt. Okay, so mass into acceleration. I am going to say that this acceleration is the double differentiation of your position xt. Correct? So if you proceed further, you will say mass into, or for economic notation you can just write x double dot t is equally correct. Okay, plus b x dot t is also correct.
Yes, sir.
Plus kxt will be equal to your applied force ft. Now try to recall your the definition of basic definition of transfer function. This was the transfer function was defined as the Laplace transform of output upon Laplace transform of input, provided system is relaxed. System is relaxed means no part of your system is going to store the energy. So what are the various parts in this particular system, mass spring damper system, which can store energy? Can anybody say?
Spring.
The spring itself, the spring can store energy in terms of what? Energy E will be equal to half kx square in terms of the position, or you can say the stretch or elongation or compression of the spring. And one more energy element should be there, or just only one energy storing element is there. Damper is somewhat like resistive element. It is dissipating element. It is not energy storing element. Try to recall the analogy. Inductor was a storing element, capacitor was a storing element, but resistor was not a storing element. It was dissipating element. So here, mass, of course, mass will be your one more energy storage element is there, that is mass, and that is half mv square, where v is your velocity. So this system can store energy, means mass can store energy in terms of the velocity of the itself, and spring can store energy in terms of its elongation or compression. Okay, so two elements are there. So what, according to the definition of transfer function, what is the meaning of that initially at rest, means a relaxed system. What is the meaning of relaxed system for this particular system?
Energy is stored.
Energy is stored. There should be no energy storage in any component of the system, and we know that in this particular example there are two components which can store energy, one as a position and one as a velocity. So initial position at t is equal to 0 is equal to 0. This will be satisfied, plus x dot means velocity at t is equal to 0 is equal to 0. If this particular equation is satisfied for this system, we will say that our system is at rest, or you can say that our system is relaxed. Okay? So this is your initial condition. Means there should not be any velocity associated with the mass, and there should not be any elongation or compression associated with the spring. Okay? Now take the Laplace transform, because transfer function was defined as in terms of Laplace transform. So take the Laplace transform of this equation 1. And let me know what you do. I am going to erase these things. This is a very basic numerical which I am solving for you, so that you can understand the concept behind very well. You know that the Laplace transform of any time varying signal is defined as denoted by that corresponding capital letter. Suppose here your position is there. Okay. So Laplace transform of this xt will be equal to what? X capital X S. Well, again Laplace transform of this velocity means first order differential. First differential of xt will be equal to what? S into xs minus a small x0. Correct? And Laplace transform of double differentiation of this position, that means acceleration, will be equal to what?
S
square xs
minus
s into x0 minus x dot 0. Correct or wrong?
Yes.
But we have already relaxed our system. We have said that transfer function is defined only for the relaxed system. What it means that initial elongation or compression of the spring is 0. By mean to say, it is equivalent to say that the initial position, that is x t is equal to 0, that is x0 will be equal to 0. So here also x0 is 0. And since one more element is there, that is mass, which stores energy in terms of velocity of itself, so velocity should also be 0 for the transfer function to be defined. So velocity is also 0. So for you, now the job becomes relatively easier. So you can just say, further you will just say the Laplace transform is just s into xs, and for this, without going into much detail of this, you will directly say that, oh, okay, the double dot is there, so s square will come, triple dot is there, s cube will come. So we are not going to bother about this element. Okay, so s square x s, correct? And accordingly, Laplace transform of ft will show somewhat like capital F s. Correct? What is input here?
X.
No. Input is your force, because you are providing the force, and position, or I mean to say that x is the output decibel. Means it is the reaction of the force on the mass, so that it is moving. Okay. So xt is your output. Okay. somebody is still saying that it is input. And Ft, applied force, is your input. But according to the definition of transfer function, what you need to find out? Not in terms of time domain, but in terms of Laplace domain. So our aim is to find out the transfer function which is denoted by GS and defined as Laplace transform of output means XS divided by Laplace transform of input, that is F. Find it out because this is very simple. Okay, let us see. So when you perform the Laplace transform to this equation, what you will get? You will get capital M S square XS plus B S XS plus K, sorry, not small, capital XS will be equal to Fs. Correct? Take the X out, XS common. XS will be equal to what? M S square plus Bs plus K. Not equality sign here. This will be equal to Fs. And you know the transfer function is Xs upon Fs. So you can say Gs will be equal to Xs upon Fs, and that will be equal to 1 upon ms square plus ps plus k is your final answer. Okay, आपने सब मेरे ख्याल से सबने सॉल्व कर लिया होगा, नहीं किया तो आपने ये और कर लिया तो सर मैच कर लिया. Okay, now note that what is the order of this system? How you have said that it is of second order?
Minus degree of the equation is
okay. In the highest degree of the denominator. Means here it is 2. So it means order is equal to 2. So this will define the order of the system. If somebody is going to ask what is the order of the system depending upon the transfer function, and watching the or noting the denominator of the transfer function and then noting the degree highest degree or equal to the order, you can find out the order. 2. What is the meaning? What is the physical significance of this? The order of the system signifies that there are 2 energy storage elements. Okay. So if by just saying the equation transfer function and by just noting the order of the system without seeing the system, you can say whatever the system may be, it might have 2 energy storing elements. And here you well known. Okay. Clear? Well, so order of the system is equal to number of energy storing element present in the system. That's all. Well. Now let us take another example. This example is for mechanical system. Now we are going to take one of the examples that is of electrical system. And try to solve. Here an electrical circuit is provided EIT with a source voltage EIT and a resistor along with in series with a capacitor, and means it is a series RLC type of circuit. You might have solved in your circuit and system. Okay. L R and this is C. I am going to say this is the voltage across this is E and current through it is I. Okay. So what is the meaning of saying that this system should be relaxed? It means I 0, that means to say I at t is equal to 0, so it is 0, and E0, that is E at t is equal to 0, voltage across the capacitor and current through the inductor should be 0, then system is relaxed. Correct? So whenever somebody is going to ask that what is the transfer function model for this system, your job becomes easier because you are not going to bother about what is the value, initial value of current through the inductor and what are the charges or corresponding voltage across the capacitor. Just you have to write the equation, take the Laplace transform, represent it as Laplace transform of output divided by Laplace transform of input. That will be the transfer function. First thing. So of course there are three elements here, R, C and L. If you are going to define, I am going to take output current from here through the inductor, then the transfer function will be different for you. If you say that I am going to read the voltage across the capacitor, then output will be different for you. Or accordingly, if you are going to say that I am going to take the output or I am going to insert or apply your voltmeter across this resistor and I am interested in the voltage across the resistor, then output will be different for you. So how the output is going to be defined, accordingly your transfer function will change. Correct or not? Correct? So I have defined that I am going to take the output from here, from the inductor. So now try to solve it. Write the corresponding equation. We have general practice that we denote input with a small rt and take output denote output as Ct. Okay, but here C has been employed for capacitor, so I am going to say that this is your Y current or voltage. Okay, so what will be equal to what? L di by d. You are interested in here. This is your output. VL is your output. And what is your input?
Voltage.
Applied voltage. Applied voltage. So this is your output. Means I am just making the things easier for you. And your input is EIT. Is your input. So what you need to find out is that you need to find out the transfer function GS, that will be equal to capital YS upon capital EIS. This is the job. Okay, now the job is defined. Find it out. Write the circuit equation, take the Laplace transform under the relaxed condition and perform this. I am also trying to solve it. You can also. So we can write if this I current will be also through the whole circuit. I. So what I can say, RIT plus ET. Okay. Plus L di upon dt will be equal to what? EIT. Correct? So before taking the Laplace transform, you have to remove this.
Sir, इसमें ET को 1/c integral I dt.
हाँ लिखिए ना, लिख के फाइनल आंसर बताइए, उसका मुझको पता ही ET को ET नहीं छोड़ना है, मैंने सही बता दिया। ईटी को हटाना पड़ेगा आपको, आई के टर्म में कुछ लाना है। Okay, just say that this is your equation 1. What else you can say? From the basic knowledge of your class 2 electrical physics, you can say that Q is equal to CV. CV means voltage across capacitor, so here it is ET. So I am going to write C into ET. Now differentiate this equation both sides. What you will get? You will get dq upon dt, and dq upon dt will be corresponding associated current with the capacitor. You will say it is IT will be equal to C. C I am going to take means the components are not dependent upon time, because we are going to take LTI system. Okay.
So SL upon
DE. Okay. You have solved?
SL upon R plus 1 upon CS plus SL.
Just let me solve it first. Then we will match that. Okay. So this will be your equation 2. Take the Laplace transform of equation 1. No. Take the or accordingly you can take Laplace transform. Laplace transform of equation 1 will leads to what? RIS plus ES plus what? L multiplied by S into IS will be equal to capital EIS. You are going to say that this is equation 3. And equation 2 will apply to capital IS will be equal to C multiplied by S into ES. And ES I want to remove from equation 3. So I will take the help of this equation. Okay. So what I can write? ES will be equal to what? IS upon C multiplied by S. Correct? So this is equation 4. Putting the value of ES from equation 4 into equation 3, what you will get? You will get, take the IS common. R plus 1 upon CS plus LS will be equal to EIS. Is your equation 3. Correct? So you have found out the value of EIS, means this particular denominator part is over. Now work on the input. Okay. Your input is this. Work on the output. Your output is this. So take the Laplace transform of this equation. What you will get? You will get YS will be equal to LS into IS. Okay. Equation 5 and equation 6. Now divide equation 5, equation 6 by equation 5. Accordingly, you can write EIS will be equal to this. Exchange the RHL and LHL. Okay. So what you will get? YS, I am going to take the value from equation 6, that will be equal to L into S into IS. Great. Now I am going to take the help of equation 5. R plus 1 upon CS plus LS multiplied by IS. In this IS and IS will be cancelled out. Okay. So finally, after a little bit of rearrangement, what you get? What I am going to do, I am going to divide both both numerator and denominator with L. So R upon L plus 1 upon CL S plus S. Correct? Multiply this equation means numerator and denominator by S, so that this denominator S will be there. Okay. So it will become S square upon higher order power. I am going to take it here. S square plus RL upon multiplied by S plus 1 upon LC. Now it is fine. Now it is fine. GS will be equal to this. How many of you have calculated this answer correctly? Only few people. 3 to 4. This was quite easy. Okay. So here, if by looking at the transfer function itself, if somebody is going to ask that how many number of components of this corresponding of this system corresponds to this transfer function stores energy. So what you will say? You will say 2. Not by looking at this, but by looking at this. Okay. We are going to focus on denominator. The highest power of S present in denominator itself will be the order of system. So this is the order of the system. Order of the system is correct. I hope the things are clear to you. Now, from these two examples, we can conclude that whatever may be the transfer function, okay, it can be represented in general polynomial form. So what I am going to discuss is the polynomial form of transfer function. Okay, means, or you can say polynomial transfer function.